always competing? And when is elimination the major product and when is substitution the major product? As you can see in both the substrates, if I use a weaker base, I end up with a substitution product. And if I use a stronger base, I end up with the elimination product. Now the selectivity, I repeat, the selectivity for elimination versus substitution. Why is there a selectivity? Now, selectivity of elimination versus substitution can be explained on the basis of hard and soft electrophiles. I repeat, the selectivity of elimination versus substitution can be explained on the basis of hard and soft electrophiles. You have learned the principle HSAB. So it is based on the same principle that in an SN2 reaction, the carbon center is a soft electrophile. I repeat, in SN2 reaction, whenever we are doing an SN2, substitution nucleophilic bimolecular. So whenever we are doing a substitution reaction, the carbon center is a soft electrophile and is uncharged. The carbon ligand, Cl matlab the leaving group, we're talking about the leaving group, Cl or the Cx, is relatively, which is sigma star, which is the antibonding orbital. The Cl sigma star is a relatively low energy LUMO. LUMO means the lowest unoccupied molecular orbital. Substitution is therefore favored. Substitution is therefore favored by nucleophile whose HOMO is able to interact with the LUMO, in other words, a soft nucleophile. मतलब अगर soft के साथ comparison हम करेंगे, तो obviously I would get a substitution product. Both their orbitals would interact to give me the desired substitution reaction, and the course would be the substitution as the major product, because I'm talking about the interaction of the orbitals based upon the principle of HSAB. Since carbon ligand sigma star is a weak center, is a weak nucleophilic center, its attack by a weak base would result in a substitution reaction. Whereas when I talk about with the hard, or when I talk about a stronger base, then the interaction would be such that the CH sigma star would become less electronegative, or then there would be less of interaction and the elimination product would be a dominant one. So when is the substitution dominant? When I have a weaker base. When is elimination the dominant product? When I have a stronger base. So this is just a basic introduction, and we've not started the chapter yet. So it is not that the chapter has just begun. We have just started with the concept of elimination. The basic thing which I would like to tell you here is that when is elimination? There is always a competition happening between elimination and substitution. When is elimination favored? When I have a stronger base, because of the principle of HSAB. When I have a weaker base, I will have substitution as a major product because of the principle of HSAB, because hard and soft will interact to give me the desired product. So this is what is being told here, and with this I would like to start with the first kind of elimination, which is the E2. What do you mean by E? Is elimination, and what do you mean by 2? It's not number 2, it is E2. E2 stands for elimination by molecular. So let us start with the elimination reaction E2, which is called as elimination by molecular. As the name suggests, elimination means to remove something. And what do you mean by bimolecular? There are two substrates which are involved, and both of them play an important role in determining the course of the reaction. So elimination bimolecular, the best example to demonstrate bimolecular reaction is the elimination of ethyl bromide in the presence of a strong base. Now you know that you have to use a strong base if you have to carry out the elimination reaction, and you would end up with an alkene, CH2, double bond CH2, and the product, which is ethanol, and and the HBr or bromide. Now the rate, they say, is dependent upon both the reactants, which is the halide, CH3, CH2, Br, as well as on the concentration of the base. So the rate of the reaction is dependent upon both the substrates, and that is why we call it as a bimolecular reaction. So why is it called? Is it justifiable? What is the course of the reaction? Why is there an elimination? So all these questions would be answered one by one. First of all, we know it is elimination, it is very clear. Why it is bimolecular? Because it is dependent upon the concentration of both the reactants. It is normally said that the rate law tells us that ethyl bromide and ethoxide are both involved in the transition state of the reaction. I repeat again, both the substrates are involved in the transition state. That is why the rate is dependent on both the substrates. For example, if the concentration of base did not play a role in determining the course of the product, I would have said it is not dependent upon the base, it is only dependent upon the concentration of the substrate, which is my alkyl bromide. If I take zyada amount, more amount, I would get more product, less amount, less product. And it is not dependent upon the base. But in this case, it is dependent upon both the reactants. Both the reactants means it is dependent upon the concentration of the base. If I use a less base, a stronger base, a weaker base, a concentrated base, the course of the reaction would change. That means because in the rate law, I have to write both the reactants because they are determining the course of the products. So when I write down the mechanism of the reaction, I see the following mechanism. Now let us write the mechanism of the reaction, and let us see that when I write the mechanism, so this is the slow step. What is the slow step? I'll tell you. And then the product is formed. Plus the Br negative plus OC2H5 negative. So all these are the side products, but this is my major product. Now we say that this is the slow step of the reaction. So let us talk about the slow step of the reaction. It is said that the E2 elimination, is a concerted. I'm using the adjectives. There are certain adjectives which need to be told here. E2 is a concerted one-step reaction. Concerted one-step reaction. The proton and the bromide are removed in the same step. The proton and the bromide are removed in the same step, which is called as the rate determining step. I repeat, E2 elimination is a concerted one-step reaction where the proton and the bromide are removed in one step. It is a slow step and the rate RDS, and it is called as the rate determining step. So it is a concerted reaction where both the proton and the bromide are removed in one step, which is the rate determining step, the slowest step of the reaction. So I think for E2 elimination, there are various other factors also which need to take into account. And let us first draw the energy profile for the reaction. So when we see the energy profile for the reaction, I can draw the energy profile and see the course of the product. So here I have my reactant, which is CH3CH2X. Here is the transition state, which is high energy, and here is my alkene, which is formed. On the y-axis, I have energy, and on the x-axis, I have the progress of the reaction. So if I can make the energy profile, also it is very clear that transition state holds the highest energy step, and it is a rate determining step. Once the transition state is formed, the reaction will go forward. So if the transition state is formed, then the reaction or the elimination reaction will happen, because the transition state, I'm using the term, please listen to it carefully, because the transition state resembles the product. So it is very important. So if the transition state formed during the reaction resembles the product, reaction goes in the forward direction. If the transition state resembles the reactant, the reaction goes in the backward direction. You've learned this, you've understood this. So this is the most important or the key step of the reaction. What we have learned till now for E2, it is elimination bimolecular, where both the reactants determine the rates, the course of the reaction. And when we draw the transition state, it is the slowest step, where the H, the proton and the bromide are removed from the same single step. That is why it is concerted. So they are removed in the same step, which is the rate determining step. Since the transition state is product-like, the product or the reaction goes in the forward direction. I hope it is clear till now, the introduction about the E2 or elimination